All right, this will be the homework help video for radicals and fractions and with distribution. I changed the title slightly on this. Your homework might look different. It might say exponential form. There's no exponential form in this homework, so you can just go ahead and cross that out. All right, I think we'll get started with a problem like number 7. So in problem number 7, there's a lot of stuff going on. There's multiple terms in the denominator. It has an irrational part. We've got some variables. So what we're going to do is we want to do our conjugate form of 1 to simplify this. But before we do that, we should remove any common factors that we can from each term. This here is comprised of 3 terms. 1, 2, 3. The terms are the things being glued together with multiplication. If they have a common factor, then I can cancel it out. Right now, it doesn't look like they have a common factor, 2a, negative 4a, and negative 3. But once I simplify this radical, they actually will. So let's focus in on how to simplify the square root of 5a to the third. I'm going to rewrite that as the square root of 5 times a times a times a. And in our jailbreak metaphor, we say that units can get out of the square root by coming out in pairs. So those a's are going to come out, and this is going to be equivalent to a root 5a. So we can make one pair of a's, so only one a comes out, and then the 5a gets left behind. All right, now if we rewrite this, we've got 2a over negative 4a minus 3a root 5a. And now each of the terms do have a common factor. It is a. You can cancel out an a there, there, and there. And now what I'm left with is 2 over negative 4 minus 3 root 5a. Now's the time to use the conjugate form of 1. To get a conjugate, you need to just simply flip the middle operator in a binomial. And then I need this to be a form of 1, so I've got to put the same thing on the top. I used an equal sign. I meant to use multiplication here. All right, at this step, parentheses can be very helpful in avoiding mistakes. So I'm going to add in parentheses here, here, and here, so that I do my distribution correctly. I'm going to distribute that 2 to both of these. And on the bottom here, I need to do foiling first, outside, inside, last. And what do I get? I'll write it down here. So I've got some room. We get negative 8 plus 6 square root 5a all over, and this is going to be a little bit longer on the bottom. Negative 4 times negative 4 is 16. We get a minus 12 root 5a. Our inside terms give us a positive 12 root 5a. We knew that those would be opposites. And our last terms, maybe I'll show some scratch work for multiplying those. Negative 3 root 5a times 3 root 5a. Let's rearrange that, make it negative 3 times positive 3 square root 5a square root 5a. This will become negative 9 big square root 5a times 5a. And then that can be simplified underneath the square root to be negative 9 square root 25a squared. Distribute that square root, we got negative 9 square root 25 square root a squared. And here's the beauty of the conjugate, is that our irrational number cancels out. And what we're left with is negative 9 times 5a or negative 45a. So that goes right there. Minus 45a. These terms cancel out. This simplifies now to negative 8 plus 6 root 5a all over 16 minus 45a. I believe that is as simplified as we go. Negative 8 plus 6 root 5a, 16 minus 45a. Negative 8 plus 6 5 root 5a, 16 minus 45a. Yeah, I'm pretty sure those matched up. So that was number 7. Let's take a look for another tricky one. Maybe something like number 13 here. This needs to be FOILed, so I gotta go first, outside, inside, last. If I multiply those first terms, you get negative root 5, or just square root 5m times the square root 3m. First, no, wait, I just did the outside. Just square root 5. Then outside is square root 5m, square root 3m. Inside is square root 3, square root 5. And last is going to be square root 3, square root 3m. All right, let's multiply what's underneath the radicals for each pair here. We got square root 25m plus square root 15m squared plus the square root of 15 plus the square root of 9m. This here is going to simplify to 5 root m. This here is going to be root 15m. After I distribute that square root, this will stay square root 15. And this will be 3 root m. The 5 root m and the 3 root m can be combined to make an 8 root m. And I'm going to put it in the order of square root of 15m, where the m's by itself, that's sort of like our linear term, plus 8 root m plus root 15. That's kind of like our constant. All right, let's take a look at the answer key for that. Make sure we got it. They put it in this order. It's all the same, but 8 root m, m root 15, square root 15. Yeah, we just put it in different order. That's fine. All right, let's take a look at 14 here. Write a quotient of 2 cubed roots so that the answer when simplified is 3a squared over 4b cubed. Then show how your quotient simplifies to the correct answer. So I need the cubed root of a over the cubed root of b to equal that. This clearly has no cubed roots, so I need to put things that when I take the cubed root of them, I will get those numbers. So the cubed root of 27, because the cubed root of 27 will give me that 3. And then a to the 6th, that way I'm able to make 2 groups of 3. All over the cubed root 4 cubed. Let me just double check that. 64. Then I need to be able to make 3 groups of b. The groups need to be of size 3, so it's going to be b to the 9th. All right, we'll just leave it at that. You still need to show how it simplifies to be the correct answer, but I've got the quotient of 2 cubed roots, and the answer when simplified is this. So I'm happy with this answer. All right, I think we'll call that good for this video. Just keep it to those 3 problems, and happy studying.